So what we're going to do is we're going to pick back up with basically domain. And when you hear me say the word domain, immediately in your head you think x values. Okay, so to determine the domain of the function, so what that is when I ask you to tell me the domain of the function, what you're going to do is you're going to tell me every single x value that you can plug into a function and that function still be defined. Okay? How do you make a fraction undefined? Denominator is going to be 0. Okay? How do you make a square root undefined for real numbers? You learned this in Math 100. How do you make a square root undefined? You cannot have negatives. Okay? So this is what I need you to be thinking. As far as your domain is concerned, when I ask you to find the domain of the function, I'm asking you what x values can you plug into the function and that function still be definable. Okay? So, a couple of things that you need to remember. We just talked about it. Numbers underneath the radical must be positive. You can't take the square root of a negative number and stay in the real numbers. We have to go into imaginary. And the denominators of fractions must not equal 0. Alright? So, if I asked you to determine the domain of each of the following functions, let's look at A. You have a basic quadratic function. Think about what a quadratic function graphs. What is the graph of a quadratic function? It's a parabola. It's a parabola. And it goes all the way from negative infinity all the way to positive infinity. It never stops. It's a continuous line. So that means that I can plug any x I want to in from negative infinity all the way to positive infinity and still get another y value, a range out. Right? So a quadratic is that way, a parabola. It's always continuous. What about a line? A line goes on forever and ever and ever. It never stops, so there's never breaks, so it's continuous, right? So any graph that you can make continuous, you can plug any x value you want into it, from negative infinity all the way to positive infinity. So for letter A, determine the domain. I'm asking you, what x values can I plug in? What would be the easiest way that you know how to write it down on your paper? Any suggestions? What is the domain for A? What x values can I plug in for A? Keep going. There's a lot more than that. Those are true, though. She said negative 1, 0, and 1. Those are 3 of them. Those are 3 of the infinitely many. How would you do it? Excellent. You go from negative infinity all the way to positive infinity. Every x value from negative infinity to positive infinity you can plug in to the quadratic, to the linear, to any graph that is continuous. So how do you know if a graph is continuous? Well, if it doesn't have a fraction in it and it doesn't have a radical in it. If your function is not a fraction and your function is not a radical, then it is continuous, which means you can plug any x value you want in for it. Okay? So the domain for letter A is from negative infinity to positive infinity. What I prefer is double bar R. How many of you have seen that before? That means all real numbers. Okay? So even if you want to write all real numbers, that's fine with me. Just let me know any x value from negative infinity to positive infinity works. Okay, so letter B. This function is a fraction, and I can make this undefined. How? If the denominator is 0. Can you tell me what number I would have to plug in, and there's only one. Can you tell me what number I would have to plug in order to make this go to 0, the denominator go to 0? I'd get negative 5 out. Okay. Give me a better number. I don't like 2.5. Yes, but I don't like it. Not 2/5. 5 over 2. 5 halves. 5 halves. How are they coming up with this number? It's right. 5 halves is right. 5 halves would make that go to 0. How did they figure that out? Yeah. If you take that denominator and you actually set it equal to 0 and you solve, okay, so let's think about what we just did. If I plug 5 halves in for x, that denominator would go to 0, right? Okay? But the question I'm asking you is determine the domain of that function. So you tell me, what would the domain for that function be? Louder? All real numbers except for 5 halves. All real numbers except for 5 halves. Now that's a mouthful, and you can write that because that's true. That is the answer. Any number except for 5 halves would be your domain. Because if you plug 5 halves in for x, because you remember your domain is your x values. If you plug 5 halves in for x, you're going to get a 0 in the denominator, and that makes it undefined. So that means if I graphed 3 over 2x minus 5, it's going to be discontinuous at 5 halves. And when we get into chapter 9, maybe, we'll talk about that a little bit more. But your domain, how you would write this is x such that x cannot be 5 halves. And it's a set, because it is a set of all numbers. It's the set of all numbers of x such that x cannot equal 5 halves. So anything but 5 halves works. Okay? So letter C. Letter C is not that easy, because there's a lot of numbers that will make this undefined. Can you tell me how first of all, what would make this undefined? If there's a negative underneath the radical. So how am I going to figure out what numbers are going to give me those negatives? It's not going to be an equal sign this time. It's going to be an inequality. So 2x plus 6 has to be greater than or equal to 0, right? 2x plus 6 has to be greater than or equal to 0, because what's underneath that radical has to be 0 or above. It has to be 0 or positive. It just can't be negative. So let's solve this. What are you going to get? So, what is your domain? Very good. Anything greater than or equal to -3. Your domain will be any number greater than or equal to -3. Okay? So, if I asked you to determine the domain of a function, you should be able to do it. As long as the function itself, now if this had a 1/2 in it, it's still doable, okay? But as long as your function is not a fraction itself, and as long as your function is not a radical, your domain is all real numbers. If you have a function that is a fraction, you just got to figure out what's going to make it go to 0, and you choose anything but. So for this one, it's anything except 5 halves. If you have a radical, you want your answers to be 0 or greater than. So you take what's underneath the radical and make it greater than or equal to 0. So any number greater than or equal to -3 is going to be good. So let's do this. Right here. Plug -3 in here and tell me what you get. 0. 2 times negative 3 is negative 6. Negative 6 and positive 6 is 0. And the square root of 0 is 0. So it works. Now, give me a number greater than negative 3. 3. Okay. 2 times 3 is 6. 6 plus 6 is 12. And the square root of 12 is 296. So it works. Okay. All right. So determining the domain. Let's work on this. Basically, just we don't want to make it undefined. Okay, so what if I give you a quadratic? Do you remember from Math 100 how to solve quadratics? You have multiple opportunities, multiple ways that you can do this. You can factor. You can use a quadratic formula. You can complete the square. I would not do that on this one. Or you can, well, I wouldn't do that one either. Or you could use the square root property, which would be ridiculous. Personally, factoring does not bother me. So that's the way I'm going to go. But look, the directions say determine the domain of the given function. Well, your given function is a fraction. So once you practice this, you should say to yourself, oh, I have a fraction. My denominator cannot be equal to 0. And that's what you're going to do. So let's take this denominator. And let's say it cannot be equal to 0. That denominator cannot be equal to 0. Now you can use quadratic formula, or you can factor. That's completely and totally your choice. This one's going to factor into x plus 3 and x plus 2, and that cannot be 0. So we're going to take each one of these. You remembering this from back in the day? And then you say a minus 3. So you have x cannot be negative 3, and x cannot be a negative 2. Okay, so have I stated what the domain is?
No, you stated what it is not.
I stated what the domain is not. And the question says, determine the domain. So in other words, it's asking you to tell me the domain. So I haven't even done what I was asked to do.
You just knocked on top of the one cell ballpark.
Exactly. So what will work? How would you write this? Do you remember how to write these things? Okay. Well, we know that we can come in from negative infinity, right? We can go all the way from negative infinity to negative 3, but not including, right? Can't include negative 3. And then we can pick back up on the other side of negative 3 and go to negative 2, but not include negative 2. And then we can pick back up on the other side of negative 2 and go all the way to positive infinity. So what in the world did I do? Well, if I was on a number line, every single number except negative 3 and 2 would work, or negative 2 rather, would work. And that's how you would write that. Do you remember how to do that?
If they all would have been included, would you have the same symbol for
Brackets. If it could be equal to, I would use brackets. And that would, but the one with the square root, we will use brackets. All right, so you got to remember how to solve a quadratic. Whether you use the quadratic formula or factoring, it's your choice. Okay, so what about this one? It's a little different. It is a radical. So we know that x squared plus 4x minus 12 has to be greater than or equal to 0, right? It has to be 0 or positive. But this time we have a quadratic that's underneath a radical. So we have two options. Here, we didn't have a choice. It cannot be 0. That's your only choice. Here, however, you do have a choice. Either it's going to be greater than 0, or it's going to be equal to 0. So you have a choice. And we have to play around with both of those choices. So the first thing we're going to do is we're going to take care of the equal to 0 part. Okay? So let's do our quadratic. X squared plus 4x minus 12 equal to 0. Let's take care of that part first. You understand where I'm getting the either or? Greater than or equal to? Okay. So now, let's see if this will factor. Is there anything we can multiply together to get negative 12, but add together to get 4? Very good. All right, so this one will factor again. Well, if I could write, that would help. All right, and then if we solve each one of these, we're going to get x is equal to negative 6 and x is equal to 2. So what does that mean? Not yet. We're just dealing with the equal to part. What does that mean? Oh, we can. What would happen if I plug negative 6? Try it. What would happen if I plug negative 6 or 2? Either one of those into that radical. Try it. See what happens. You get 0. Is that good? Yeah, you can take the square root of 0. The square root of 0 is what? 0. So are those two numbers in your domain? Absolutely. Absolutely. So now what we've got to do is we've got to take care of the greater than part. So we did this in 100. So what you're going to do is you're going to set up a number line. We already know that those two numbers are good. We already know that those two numbers are good. What we don't know is all the other numbers on the number line. We don't know anything about all the other numbers on the number line. Well, when I put those two numbers on a number line, how many segments does it break the number line into? 3. 1, 2, 3. And this is what I want you to do. I want you to pick, and it's totally your choice, pick a number out of each of those 3 segments. Pick a number out of each of those 3 segments. So give me a number out of segment 1. Okay? Give me a number out of segment 2. Always use 0 if you can. Give me a number out of segment 3. All right. So, and you can use 3. That's fine.
Negative 5 on the other side of things.
Yeah. So let's pick another number here. What do you want? Negative 8. That'll work. Okay. So this is what I want you to do. And I don't really care about the numbers. I more care about negative or positive, okay? Because if you get a negative number underneath a radical, it's undefined. But if you get a positive number, it's good. So let's do this. Plug negative 8. Basically what you're going to do is you're going to find f of negative 8. This is good practice for your test tonight. F of negative 8. So you're going to have negative 8 squared plus 4 times negative 8 minus 12. What do you get? Calculator. Louder. Which is what? Help me. 20? So that's a positive number. Is that good? Yes. Then every single number in that segment is good. So we're building our domain. Now we've got a whole bunch of more numbers in our domain, right? Okay? What about segment 2? Let's find f of 0. What are you going to get? Square root of negative 12. Bad. No good. So nothing in between negative 6 and 2 will work. None of those numbers will work. You can throw those out of your domain. So what about f of 5? What are you going to get? 33. Is that good? Absolutely. Okay. So now can you tell me what the domain is? In your own words or mathematically speaking? Excellent. Excellent. You have just copy down off of your number line from negative infinity, and we can never include negative infinity, right? So it's always going to be a parenthesis. From negative infinity to negative 6. What are we going to put at negative 6? A bracket, because it can be negative 6. We proved that to the left. Or union, whatever you want to use. What are we going to put at the 2? a bracket as well, because we proved it here, and then all the way to positive infinity. That is your domain. So quadratics are a little bit rougher, but you learned how to do it in Math 100. The only thing we're doing is taking what we learned how to do in Math 100 and stating the domain. That's all you're doing. Okay? Just adding one more step. Okay?
Because right now on 81, you want to set equal spread and then check on the number line.
Mm-hmm.
Would there ever be a time when we just want the straight to greater than or equal to for it to be long equal?
Well, you have to check it on the number line because you don't know which intervals are going to make it positive.
Okay.
I mean, I would like to say that it's always going to be a union, but that's sometimes not my case. Okay, linear functions. This is going to be easy stuff. Easy. How many of you remember graphing linear equations? Writing linear equations? We love graphing, right? Graphing is so much fun, yes? Graphing is awesome. Compared to the other stuff that you're going to do in this class, you're going to love graphing. I can assure you of that. Okay, so some formulas that we need to know. Slope. All right? First thing, little m. You always know little m means slope, yes? All right. So if we have 2 points, we can find slope by finding the difference of the y's over the difference of the x's. That's because you have your i's over your run. So, just for fun, find the slope between these 2 points. Find the slope between these 2 points. Negative 1. Right? y2 minus y1, negative 5 minus 2 is going to be negative 7, over x2 minus x1, which is going to be 4 minus a negative 3, so I guess double negatives plus. And then negative 7 over 7 will reduce to negative 1. Everybody remember how to find slope? Okay. So, to determine linear functions that satisfy certain conditions, you must be able to recognize the conditions given and manipulate equations to find what you need. Read that one more time to yourself. Okay, so what 2 equations are we talking about? Well, actually, there's 3 equations. We have slope-intercept form. Can you tell me what slope-intercept form is? Y equals mx plus b. You have standard form. Does anybody remember standard form? Ax plus by is equal to c. And then your point slope. Do you remember point slope? Y minus y1 equals m times x minus x1. Those are the 3 formulas that you need, okay? So again, slope-intercept form. You have, and of course we are talking about functions, so you have f of x is equal to mx plus b. You have standard form, which is ax plus by is equal to c. And then you have point slope form, which is y minus y1 is equal to m times x minus x1. All of these you need to have in your brain. Okay? So, when I ask you to write a linear function, I'm asking you to write a linear equation in functional notation, of course, okay? So, to do that, look at what I told you up top. To determine linear functions that satisfy certain conditions, you must be able to recognize the conditions that are given to you. So let's look at the example. It says, write a linear function with the slope of 1/2 containing a point of 10/4. What have I given you? Yes, in particular, specifically, what have I given you? Don't overthink it. I've given you a point and I've given you a slope. I've given you a point and I've given you a slope. So I would write a linear equation using point slope. However, on the test it's going to say write your function in either standard form or slope-intercept form. Okay? So for this one, I want it in slope-intercept form. So write a linear function in slope-intercept form with a slope of 1/2 containing 0.104. Now, in high school or in your previous Math 100 class, you may have learned how to use slope-intercept form, plug in, find v, and then rewrite it. If that's the way you know how to do it, go for it. I'm not the math Nazi. If you can do this, do it. Okay? I, however, prefer, if I'm given a point and a slope, I'm going to use point slope. That's why it was named point slope. So, you're going to have y minus y1 is 4 is equal to your slope, which is 1/2, times x minus x1, which is 10. The one with the subscripts of 1, that's your point. The y and the x that do not have subscripts, that's going to be in your actual equation. Okay? So we have y minus 4 is equal to 1/2 x minus 5. Now what form did I want it in? Slope-intercept form. So what does that mean? Y has to be by itself. Y has to be by itself. So all I have to do at this point is add 4 to both sides. And I get y is equal to 1/2 x minus 1. Write it in functional notation. And you're done. So you just wrote a linear function in slope-intercept form that has a slope of 1/2 and it goes to the point 10 point. We did this in Math 100, I promise. It was the last chapter you did, chapter 7. Okay, determine the linear equation whose graph is a line that contains these 2 points. Now, something that you need to write in your notes right now and put a big, huge star by it, arrows pointing to it, highlight it, and everything else. Before you can write a linear equation, you have got to know slope. You can't do anything until you know slope. So if I ask you to write a linear equation, linear function, you have got to know slope. Well, in the previous problem, I made it easy on you, didn't I? Did I give you slope in this problem? Yes, so I made it easy on you. But I don't have to give you slope. I can give you 2 ordered pairs and make you find slope. Okay, so let's do that first. Let's find slope. M equals y2 minus a y1 is over 4x2 minus x1. So y2 minus y1 over x2 minus x1. And so you're going to have what? 6 over 6, which is 1. Is that what you got? Yay. Okay. So it says determine, and on the test it's going to tell you which form I want it in. So let's go for determine the linear function in standard form. Okay? Determine the linear function in standard form whose graph is a line that contains these 2 points. Well, we now know slope. So where are you going to go? What you going to do? That's what I would do. So I would use point slope. But Miss Adams, I don't have a point. Really? How many points do you actually have? You have 2. Which one are you going to use? Either one you want to. You can use any point that you want to. So now you have a point. You actually have 2. And you have a slope. Pick a point, any point. Doesn't matter which one you want to use. 4, 3. Sounds good. Okay. So you have y minus y1 is equal to my slope that I just found times x minus x1. Now one thing I will tell you is this. If you choose the y out of one point, you have to choose the x out of the same point. Okay? You can't be wishy-washy. Okay. So here we have y minus 3 is equal to x minus 4. Now I want it in standard form. What does that mean?
Y has to be by itself.
That's slope-intercept form. I don't want slope-intercept form, I want standard form. y have to be on the same side equal to your constant. Can you do that for me? Manipulate this equation to where x and y are on the same side equal to a constant. And there's a few more stipulations, but we'll talk about those in just a second. So if I add 3 to both sides, I'm going to have y is equal to x minus 1. Is that what I want? No. That's slope-intercept form. That's wrong. I want standard form. So let's get x on this other side. So we'll have minus x. So we'll have negative x plus y is equal to negative 1. Now let's see how good your memories are. Is this standard form? Beth? You cannot have a negative leading coefficient. You can't have a negative x. Standard form actually has 3 rules. 3 rules for standard form. Number 1, and you'll like this one, no fractions. Number 2, x coefficient must be positive. And number 3, x and y same side. Okay, so how are we going to fix this problem?
Flip it so it's positive, minus 1 is constant 1.
Mathematically, yes, but mathematically speaking, we're just going to multiply through by a negative 1. So I'll have x minus y is equal to 1. Okay, so if I ask you to write a linear function, what's the first thing you've got to know? Slope. And sometimes I'll give it to you and sometimes I won't. But if I don't give it to you and I give you 2 points, you can find it, right? Use that formula. Okay, what do you remember about parallels and perpendiculars? Parallel slopes are the same. Perpendicular or opposite. You had a great mathematics teacher. Who was it?
Mr. Boyd.
Sorry. Oh, you had me for a moment.
I did.
But you had a great mathematics teacher, right?
I did.
I thought I had you for 100.
No, because I expected it was
Oh. Anyway. I was like, what? Okay. Okay. Parallels and perpendiculars. Parallels have the same slope. Just out of curiosity. No, that's another question. I'm going to talk to you later. Okay. Parallels have the same slope. Perpendiculars have opposite inverse slopes. Okay, opposite signs. One's positive, one's negative. Inverse means fraction has to be flipped. Okay? So, look at this. All lines that are parallel will have the same slope, and all lines that are perpendicular have opposite inverse slope. So you're going to use this information to find the linear functions that are parallel or perpendicular. So here's your example. Determine the linear function whose graph is a line that is parallel. So let's just stop right there. We're looking for a linear function, and I want this in slope-intercept form. Okay? Yeah, I want it in slope-intercept form. Determine the linear function in slope-intercept form that's going to be parallel to this line, g of x is equal to negative 2x minus 4, and contains the point 2, 7. So let's stop and let's think. I'm asking you to write a linear function. What's the first thing you've got to know? Slope. Okay? So I'm asking you to find a linear function that is parallel to this one. Can you tell me slope? Negative 2 over 1. So you already know slope. Your slope is negative 2, and if you want to put it over 1, you can. And the line that you're finding, the function that you're finding, has to go through point 2, 7. So now, what information do you have? Very good. You have a point and you have a slope. So here we go again. Y minus, what is y1 going to be? 7 is equal to slope. What is that? Negative 2, because we are going parallel. Times x minus 2. Alright, so we have y minus 7 is equal to negative 2x plus 4. Add 7 to both sides. And we have y is equal to negative 2x plus 11. And we've done it. Do you remember this? It's a lot. But if you pick it apart and you know what I'm asking for, then it's not that bad. Determine the linear function. In order to write a linear function, you've got to know slope. Period. I didn't give you slope and I didn't give you 2 points. So you're sitting there looking at your test and saying, now look, she told me that if I want to find a linear function, I've got to know slope. Well, she didn't give it to me and she didn't give me 2 points. How in the heck am I supposed to know what slope is?
You gave us a finished line.
I gave you 2 hints, right? Number 1, parallel. And number 2, I gave you a line that's parallel that has the slope in it. So technically, I didn't give you slope. Okay. And from there, you should know what to do. What? Technically, but I'm not going to do that for you. Okay, so let's go with perpendicular. Let's go with perpendicular. It says determine the linear function whose graph is a line that is perpendicular to the line g of x is equal to 5x minus 2 and contains the point 6, 3. In order to write a linear function, what must you know? Slope. I didn't give it to you, did I? Kind of, sort of, in a roundabout way. Kind of, sort of, in a roundabout way. Okay, this is going to be math chaos, so we can do this. Tell me the slope that you're going to use in your point slope formula.
-1 day.
Very good. The slope here is 5 over 1. That's not what I want.
It has to be inverse and opposite.
Opposite inverse. So your perpendicular slope is going to be the opposite sign. So I started out with positive, we're going to go with negative, and we're going to flip this fraction. That's the slope that I want. Opposite inverse. That's the slope that I want. Alright, so let's go. Y minus 3 is equal to my slope times x minus 6. Right? Alright, let's distribute first. Negative 1/5 x plus 6/5. And then let's add 3 to both sides. And so you're going to have y is equal to negative 1/5 x. Handy dandy calculator. 3 plus 6/5. 4 and 1/5. If you don't like that, that's fine. Either way. Okay? Let's do combining functions. So what happens if you have 2 or more functions and we need to combine them? Combining of functions. Well, you did this in Math 100 as well, or Math Algebra 1, whatever your case may be. It's just you've never seen it written in functional notation. But when I show it to you, you're going to be like, oh, okay. So, basically combining functions, we're going to add them. So if we have 2 functions, f of x and f of g, and you see it written like this, this says to take f of x and add it to g of x. F of x plus g of x. Subtraction, same thing. F of x minus g of x. Now you know f of x and g of x are just polynomial functions. So you know how to add polynomials, right? Combining like terms. You know how to subtract them. Multiplying, you're going to FOIL it out, distributive property, whatever. Division is a little tricky. Most of the time you can't even do anything with it, but number 5, that's the new stuff. Okay? 1 through 4 you should have already learned, and then 5 is the new stuff, and we probably won't even get to it today, and that's okay. So again, let's have a little bit of fun. Here are your 2 functions. If you have f of x is equal to 2x plus 3, And you have g of x is equal to x minus 4. Find and state the domain. Gotta throw in a little bit of something. Find and state the domain of each of these. Find f plus g, f minus g, f times g, and f divided by g. Now, you're thinking, seriously? Yeah, it's really that easy. F plus g is going to be 2x plus 3 plus x minus 4. Combine your like terms and you're going to get 3x minus 1. What is the domain? Oh, yay. All real numbers. All real numbers. There's no fraction. It is not a fraction and it is not a radical. Therefore, it's all real numbers. Okay, let's do f minus g. So we're going to have 2x plus 3 minus x minus 4. Well, 2x minus 1x is going to give me x. And 3 minus a negative, so that's going to go to plus. 3 plus 4 is going to give me 7. What is the domain? Yay. Okay. Multiplication. So we're going to have 2x plus 3 times x minus 4. How do you do this? Very good. So you're going to have 2x times x is going to be 2x squared. 2x times negative 4 is negative 8x. 3 times x is 3x. And 3 times negative 4 is negative 12. So I have 2x squared minus 5x minus 12. What's the domain? Yay. Alright, for number 4, you have 2x plus 3 divided by x minus 4. Okay, think. Don't speak, because I don't want you to embarrass yourself, but think to yourself. Answer to yourself. Is there anything that I can do to this problem to simplify it? Is there any way that I can simplify this division or actually do the division to this problem? Don't answer, because I don't want you to embarrass yourself. The answer? No. The answer is no. So let's think for just a second. 2x plus 3 is a group, and x minus 4 is a group. What is the only way that you can cancel groups? If there's another group exactly like it somewhere else. And there's not. Some people want to say, oh, well, I can reduce the 2 and the 4 to get 1/2, and I can reduce the x's and get rid of those, and then I'll have 4 over negative 2, which is negative 2. No. You cannot cancel these because they're in a group. The only way you can cancel a group is if there's another group somewhere else. Okay? Do you remember that vaguely? That would be chapter 4 in that book. Chapter 4 in your Math 100 book. Or in that book. Easy enough?